This is Josh Mandel back with another episode of a guided walk through FHIR, and we are going to resume our treatment of the FHIR clinical safety checklist. And if we think about where we left off, we had covered the first 8 items on the list and made our way down to number 9. My system publishes a capability statement with structure definitions, value sets, operation definitions, etc. So other implementers know how the system functions. So this is a big topic and includes a lot of links, and we will really just use this as kind of a touching off point. We're not going to have time to talk through each of these in great detail, but I want to spend a few minutes and talk about the goals of the capability statement in FHIR as we get started. And the idea of a capability statement is, as we write here in the spec, it's a key part of the overall conformance framework. It's used as a statement of the features of actual software or of a set of rules for an application to provide. And it connects to all the detailed statements of functionality. So the idea here is that different systems can publish their own capability statements. And let's look at a couple of ways in which this plays out kind of in real life. One is describing a set of capabilities that software might have, and the other is describing an actual implementation. And if this sounds a little bit abstract, let's go ahead and try to make it concrete. So when we talk about describing an actual implementation, this is what happens when I want to talk to a FHIR server and ask that server, hey, what are the things that you are capable of doing? And let's just take a look at maybe happy.phir.org, which is a public testing server that should host a capability statement for us. And in general, the way that you ask a FHIR server to produce the capability statement telling you what that server does is to call the metadata endpoint on that FHIR server. You could also search a FHIR server for capability statements. And so what this means is, tell me about all the capability statements you have stored. And we'll get back a bundle of, in this case, there's 100 different capability statements. But this is not telling me what this server is capable of doing. This is just kind of a repository of statements. These might be different statements that came from all kinds of different servers that this one connects to. So searching for capability statements generally isn't how you figure out what a given server can do. Instead, you call the metadata endpoint, and it responds with just a single capability statement, which is, here's the things I can do, this particular server. And it includes details about the kind of software. So we see this as an instance, meaning it's a particular server that we're going to learn about here. The name and version number of the software. So this is version 5.5 of Happy. It's got the URL, although I kind of already knew this URL, given that I called this server's metadata endpoint in a RESTful context. But there's other places where FHIR can be used outside of a RESTful data exchange. And so knowing the URL might not be so obvious in those cases. That's why it lives here in the capability statement. What version of FHIR is supported, what data formats, so what different serialization formats like JSON or XML does this server support. And then for a FHIR REST API server, there's this REST array, which is going to tell us about all the different REST API endpoints that the server supports. And you can see here they're going to be alphabetically sorted in this server. So the first one is going to be the account endpoint, which deals with a FHIR account resource. And then the next one is going to be I might have scrolled past it. There's a very high density of information that now we get down to adverse event, and eventually we'll get down to something like patient here at line 17,773, which does bring me to an important point. These capability statements are quite detailed and they can get quite large because not only does this tell me this server supports the patient resource, but it can also tell me about some specific profiles on the patient resource that the server might have support for. So here's a profile from the World Health Organization. Here's a profile that just happens to live on this particular server. There's a whole array of these different profiles for the patient resource that the server might have some special support for. And then here's a list of which interactions I can do with the patient endpoint. I can create, delete, search, and so on. When I search, here's a bunch of parameters telling me exactly which search parameters I'm allowed to use. whether the searching functionality supports the FHIR include directives or reverse include directives. all kinds of details that are going to tell me, specifically how this server behaves. You can see a lot of the text here has to do with the specific search parameters on the patient endpoint that are supported. And then we get down to a list of operations on the patient endpoint. So in addition to searching for patients and creating and reading, I can also perform some custom operations on the patient endpoint, doing things like listing all the data in a patient. That's the patient everything operation. Expunging data, validating a patient, calling a GraphQL expression. All those are just the details about how this server works with the patient resource. And then on to the next alphabetically ordered resource, which is payment notice. So that's a little bit about what a FHIR capability statement looks like when you interrogate an actual implementation, in this case, the happy server at happy.phir.org. So what then do we mean when we talk about describing software solution capabilities or describing a desired solution? What are these all about? And I'll show you an example for these as well, I guess from the perspective of a desired solution. So I'm going to look at the FHIR bulk data specification, which is here at hl7.org/uv, universal realm /bulk data. And the reason I pull this one up is that I know that we have published in this specification a few capability statements. And so these capability statements actually describe what a server needs to do if it wants to conform to this implementation guide. So we have a capability statement here called Capability Statement Bulk Data. And let's view it in JSON if we can. That didn't seem to work. Let's try the raw JSON view. Okay. So I'm just going to open that one up in a text editor. And we'll just take a quick look here. So what does this capability statement look like? I'm going to delete the narrative text because it just takes up a lot of space on the screen. But it's got a version and a name and a title. So it tells us this is the FHIR Bulk Data Export Implementation Guide capability statement. It's got information about when it was published, who published it, who are the right contact people to be used, to be contacted if there's questions about this. There's me, if you want to contact me at my Boston Children's Hospital email address. And here's a description that basically says this is going to tell us about all the expected capabilities of a FHIR bulk data server. So in this case, it's not telling me about any particular server, but it's listing the expected capabilities that a compliant server would support. And if we get into the meat of it, here we've got, similar to what we saw in the happy case, a REST API endpoint. And what this one is going to tell us is it's going to have some support for security. But here's what I want to take a look at, which is the list of operations that are required. And we say there's one operation called the bulk data export operation that this capability statement says conformant servers should support. And then there's an operation called patient level export and another operation called group level export. And I won't focus on the layout of the details in this file because there's actually a couple of errors that are being corrected in the latest publication. But I just wanted to show this to you to get a sense of why an implementation guide like FHIR bulk data might include a capability statement. It's basically saying here's the things that a real server should have if it's going to be following the requirements of this implementation guide. And we say one other thing here in the FHIR bulk data implementation guide. We say any server that wants to declare its conformance, well, that server should publish in its own capability statement, it should publish an instantiates property. So capability statement.instantiates that would point to this overarching capability statement representing what this implementation guide requires. And so this provides kind of a link from what a real server would do in practice to this definitional artifact, this capability statement that we publish in the specification itself. So we can look and see if the happy server actually declares any instantiates, and it doesn't, at least not at this point in time, which is interesting because I think it does actually support the export API. but it doesn't necessarily declare its support for the export API. And that's something that we might want to actually report back to the Happy team. We'll see if it makes sense to include this instantiates property the way we specify here in the bulk data implementation guide. So that hopefully gives you a little bit of intuition for what it means when we say that capability statements can represent an actual implementation, or they can describe software solutions or desired solutions for requirements. And you can think of what we publish in the implementation guide as sort of falling into these categories. So that's what the capability statement looks like from a couple of examples. And now maybe it makes sense to take a quick look at the actual resource definition tree here in the FHIR spec now that we've seen a couple. We can see that there's a whole lot of metadata that tells me URLs and names and dates about when this server or when this capability statement was put together. A capability statement can point to other capability statements as a way of saying this server supports or instantiates the functionality defined somewhere else. So this is the requirement that we looked at in bulk data for a server to say that it supports what's defined in the bulk data spec. And then the server can get into the details of like which REST API endpoints it actually supports, which specific resources within the REST API are hosted, which search parameters are supported. That's the search parameters array within that resource type, and all kinds of details about like the specific flags and different options and features that a FHIR server can support. Because the FHIR server, the FHIR API overall is quite rich and flexible, and there's a lot of different options that a server might support or might not support. And the value here is that rather than just publishing a description in your developer docs, you can publish the description following this resource definition in a machine-readable way so that software can be sure that it's only asking you for things that you're able to handle, only calling you with search parameters that you know about, or only invoking operations that your server declares support for. So that's a little bit about what it means for my system to publish a capability statement. Now what about with structure definitions? What is that all about? And value sets and operation definitions. So let's actually take a look back here through that same table and see where we talk about structure definitions. So here's the first place. Within my capability statement, when I'm talking about my REST API endpoint, and I'm talking about a particular resource type, like the patient resource, here's where I can describe optionally one base system profile for all uses of the resource. So maybe my server always requires that all patients in it be valid US core patients. That might be quite limiting, but if that's how my server behaves, I could include this link, this profile link, back to the canonical URL for a structure definition. So just to be concrete, if we wanted to say something like that, we would look at the FHIR US core implementation guide. We'd look at the profiles here for US core patient, and we would grab this defining URL, also known as a canonical URL. So if I look at the definition for this FHIR core patient, or US core, we can see it's a structure definition resource with this ID. And let's get past the narrative text block, which is quite unwieldy here in the JSON rendering, and we get the canonical URL. And this is going to match what I copied from the human rendering on the last page. But anytime I want to talk about the FHIR US core patient profile, this URL refers to it. And ideally, if I paste this into my browser search bar and go there, ideally that would actually resolve to the relevant profile. It would take me to this very page, or maybe this overview. Maintaining those links and getting them to work all the time is apparently an ongoing challenge, and so I think our success rate there is still somewhat limited. But that's the intention, is that somebody who wanted to refer to the resource, this structure definition, would use this URL. And ideally, following this URL would take us back to the structure definition to kind of complete the cycle. So in my capability statement, if I wanted to say that this was the profile that all my patient resources had to meet, I would populate this particular element, capabilitystatement.rest.resource, specifically for the patient resource, .profile. I would populate that with the URL that we looked at a moment ago. And we can also point to a set of supported profiles. And you'll notice that this is flagged as standard for trial use. We don't have as much implementation experience with this supported profiles array, but the idea is maybe I don't require all patients in my server to be US core patients, but I do have some special handling for US core patients. Maybe I've got a half a dozen different supported profiles that I have some use cases that I support, and I could list links to all those structure definitions here on my patient resource, or on my allergy resource, or my observation resource, or whatever the relevant resource type might be in my in this array of resources in my capability statement. So those are a couple places where capability statement points to structure definitions or profiles. And I think those are the main ones that I would highlight in this overview. So the safety set checklist says we should also look about in the capability statement for information about value sets that my system is going to support or use in some way. So let's search through this page for value sets. We don't find much, as it turns out, but there's a couple matches. So one is at the very beginning of the capability statement page when we talk about project scope. We say this capability statement connects to all of the detailed statements of functionality such as structure definitions and value sets. Okay, I didn't actually see that, but I do see it described in the intro. Where do we actually talk about value sets concretely? Right here. So capability statement dot jurisdiction. That's maybe a field that it's bound to a particular value set. Okay, but I don't see a place in the capability statement itself where a server is listing particular value sets. That's really happening through the set of supported profiles. So let me just make that a little bit more concrete. Let's say, again, we're talking about our resources array. We're talking about the resource type of patient. And let's say we have a supported profile for US core patient. Well, if we look at the US core patient profile back in the US core implementation guide, we're going to see things like, let's just open up the snapshot table here. We're going to see things like FHIR, like US core race, or US core ethnicity, or US core birth sex. And so all of these have their own value sets associated with them, and the value set binding is described here in this last column. So for birth sex, for example, if I click on this value set binding, I can see there's an extension for birth sex, and the extension includes a coded birth sex, and that is what's actually bound to a birth sex value set. So I've gone through several links here. I've gone from my capability statement to the patient profile, to the birth sex extension, to the birth sex value set. But software can follow all these links, and so it can go from knowing where a server is, to seeing what profiles it supports, to seeing what extensions and value sets those profiles need. And so in the case of that birth sex value set, this would be a value set including terms like male and female and unknown. So several links to get there, but eventually this does resolve back to a set of values that would be used in that context for this particular server. So I think that's what we're getting at when we talk about my system describing the value sets that it needs or that it supports. Not directly, but through references to the set of structure definitions or profiles. And then we also call out operation definitions. And we've talked about the FHIR operations framework in this series before, so I won't focus on how the operations framework works, but you can go back and see the video on that if you're interested in learning more. But I will talk about where this fits into a FHIR server's capability statement. And the idea here is that within the FHIR capability statement, when you're listing all of your REST API capabilities, and you're listing a given resource type within those, you can say, here's the operations that I support. So there's this operations array. This defines a resource operation. And so this would be at the level of something like patient/$ export. So that's one place where a capability statement can point to the operation definitions it supports. It's a link out, again, a canonical URL pointing to an operation definition. So if we grab an example from FHIR bulk data again, we can see that the operations defined in FHIR bulk data each have a canonical URL. So let's say group export. Well, the canonical or official URL for the group export operation looks like this. I'm curious to see if this one resolves, so I'll try pasting this into my browser, and this one actually works pretty well. So sometimes we get it right. But in my capability statement for my server, I would populate, within the group resource, I would populate the operations array to include an entry that points to that canonical URL. So definition would point to the URL that I just copied onto my clipboard. And then there's also a required parameter called name. And typically, any given operation will always have the same name. So the group export operation, for example, is typically called export, and it lives at the group resource level. But technically, and this is a pretty subtle and obscure point, technically anyone can publish an operation definition. And so somebody else in the world who has nothing to do with HL7 and HL7's publication process, someone else could also publish an operation definition for group that might also want to be called export. And in general, that's okay, because we don't refer to these operations by a simple name like export. We actually refer to them by this canonical URL. And so no one else in the world can publish an operation called this, even if they can publish an operation that uses this name. So the canonical URL is a powerful definitional construct, and it's totally unambiguous. This is nice for human readability, but it can be, in some cases, ambiguous. And so when your server is advertising that it supports a particular operation definition, it will also advertise the name at which that operation definition is sort of hosted or mounted or offered. And so typically you would just put the name export here if you were describing your support for the export operation. But if you had to disambiguate because you wanted to support two different operations, you could give it a name like export2 or export FHIR bulk or anything you want. And in theory, clients would always check the name of the operation so that they could call it appropriately. In practice, I think that is very unlikely to work. Most clients just hard code the name of an operation and they'll say $export when they issue a query. And so I would expect that any behavior that depends on clients really paying attention to this field is going to be pretty brittle and pretty broken in real world implementations, but that's at least how the standard expects this field to work. So we've talked about how a system can publish a capability statement, pointing to structure definitions, which in turn point to value sets. The capability statement also directly references operation definitions at the level of a resource type, but also at the level of the server root. And I think I have to scroll down to find that. But we can see the operations appear in a couple of places here, because operations can be hosted at the system level or at the resource type level. So we've seen how the capability statement can point to these operation definitions, and this helps outside parties know how the system is going to function. So that's our whirlwind tour of FHIR capability statements for today. I will say this is an area of active development in the FHIR spec. So even though capability statement and most of the content that we've looked at is normative level maturity and won't be changing, we've also recognized that there's a very long tail of features that a FHIR server might support. And this resource could get awfully big, and the definition could continue to get more and more complicated as that set grows. So we're exploring ways to try to make this a little bit more rationalized in the future. And so in the FHIR build site, there's a resource called Capability Statement 2, which is kind of a placeholder. You can see we listed it here at maturity 0. We probably won't publish a resource called this, but we might borrow some ideas from this placeholder content. And the idea is really to describe features in a more flexible way. I won't talk through it in this video, but if there's interest, we could talk about this in a follow-up video. But this is the basic concept that I would point folks towards if they're interested in learning more about where the capability statement might be going in the future. My final thought is actually just to say, declare myself as a little bit of a capability statement nihilist. I think it's really hard to express the full behavior of a system in these kinds of structured documents. And in a lot of cases, you don't necessarily need to communicate every last nuance. A client can just try to issue some kind of API call, and either it works or it doesn't. It gets a successful result, or it gets an error. And ultimately, maybe the capability statement says I can do X, but in real life I can't, or it doesn't mention Y, but in real life I can do Y. And so there's always this kind of distance between what a capability statement says and then what the server actually really does in real life. So I think capability statements are probably most useful from a conformance testing perspective and from a sort of high-level communications perspective, I don't know that they're going to be super useful communicating all of the detailed features of a server. But that's a little bit of a fringe opinion, and I will say there's a lot of folks in the community who have more faith in it than I do. So we'll wrap up there and look forward to seeing you next time.